Why is there something rather than nothing? How did everything begin? What was there before the beginning? Where did the material come from that created the Big Bang? What happened in the first instance to create that material? Why are we here? When it comes to understanding the universe, trust me, we've barely scratched the surface. These questions I asked above have been circulating in the realms of human curiosity for countless generations, transcending time and spanning cultures. We've been sending different telescopes, like the James Webb and Hubble, to explore the depths of the cosmos. These marvels of engineering have actually done a great job in unraveling some of the universe's secrets, possibly shedding light on a small fraction of its vastness. Day in and day out, we've diligently scanned the skies, capturing breathtaking images of distant galaxies, nebulae, and celestial phenomena, expanding our knowledge of the cosmos with each observation. Through these telescopes, we've witnessed the birth and death of stars, marveled at the intricate dance of galaxies and cosmic collisions, and unraveled the mysteries of black holes. We've measured the redshift of distant galaxies, allowing us to peer back billions of years into the past, offering a glimpse of the universe in its infancy. But with all of these magnificent discoveries, we still have numerous unanswered questions. Everywhere, why, when, how, where, can we ever answer these questions? Well, you have to keep watching. Theories. The last star will slowly cool and fade away. With its passing, the universe will become once more a void without light or life or meaning. This statement was mentioned by physicist Brian Cox in a BBC series. This is how everything might end. Some other theories suggest that our very own Big Bang, the genesis of our universe, might have originated from a previous incarnation of emptiness, a cold, dark, and empty universe similar to the one awaiting us in the distant future. This is just the first theory. What about theory 2, which suggests there is no first man or woman, no singular event that sparked the universe into existence? Instead, the universe has always been and will always be, existing in a state of perpetual existence. According to this theory, the cosmos undergoes an unending series of expansions and contractions, with each cycle seamlessly transitioning into the next. It is an eternal cosmic dance, where the fabric of reality remains constant, unaffected by the passage of time. This theory challenges our conventional notions of a linear timeline and a definitive origin. It suggests that the concept of before and after loses its meaning as the universe persists in a state of unending existence. It invites us to reimagine the nature of reality itself, where the eternal cosmos encompasses all possibilities. And then theory 3 takes us even further, suggesting the existence of infinite universes, each with its own set of physical laws, constants, and conditions. According to this theory, our universe is just one among an infinite ensemble of parallel universes. Each universe within this vast ensemble may have different properties, leading to a staggering array of diverse realities. Every conceivable outcome and configuration exists, encompassing an unimaginable breadth of cosmic landscapes, from universes where the laws of physics are entirely different to those where life takes on forms we can scarcely imagine. Strange, right? The next one, Theory 4, suggests that the reality we perceive as the universe is, in fact, a sophisticated program created by an advanced civilization or a higher intelligence. In this scenario, our entire existence, including the laws of physics, the fundamental particles, and even our own consciousness, is a product of an intricately designed computer program. It proposes that what we perceive as the physical world is a complex virtual construct, akin to some sort of hyper-advanced video game. Supporters of this theory argue that the rapid advancements in technology and computing power, along with our own efforts to create realistic virtual environments, point towards the feasibility of such a universe. They propose that an advanced civilization with incomprehensible computing capabilities could create a simulated reality that is indistinguishable from the real universe. Well, I've given you about 4 theories. If you know the names of these theories, make sure you comment their names below. Let's continue. You see, the universe is very strange. We've got particles popping in and popping out of existence everywhere. There's something, and then pop, nothing. We've got dark matter, a mysterious substance that makes up a significant portion of the universe's mass, but remains invisible to our current methods of observation. It does not emit, absorb, or reflect light, yet its gravitational effects can be observed in galaxies and the large-scale structure of the universe. We've also got dark energy, which seems to be expanding the universe with immense speed. Unlike gravity, which acts as an attractive force, dark energy seems to push galaxies apart, causing the fabric of space itself to stretch. This expansion occurs on such a grand scale that it surpasses the gravitational forces between galaxies, leading to an ever-widening cosmic expanse. And then we have the Big Bang, which tries to explain the origin and evolution of our universe. The universe, as we know it, began from an incredibly hot and dense state approximately 13.8 billion years ago, suggesting that all matter, energy, space, and time originated from a singularity, a point of infinite density and temperature. In an extraordinary event, the universe rapidly expanded and continues to expand to this day. It was during this expansion that the fundamental forces and particles that govern the cosmos came into existence. But is it perfect? Did the Big Bang happen inside space, or was the Big Bang the beginning of space itself? Where did it happen, and how did it happen? Why did it happen in the first place? You see, the Big Bang Theory gives us a remarkable glimpse into the birth of our universe, but there are still many unanswered questions. We may have an idea of what happened after the bang, but what happened before the bang is where we are left hanging. How could all matter, energy, space, and time be packed into a point of infinite density and temperature? It boggles the mind. Strangely enough, some cosmologists entertain the idea that a previous incarnation of emptiness, a cold, dark, and empty universe similar to the one awaiting us in the distant future, could have been the source of our very own Big Bang. This may sound confusing, but let me explain what I mean. First off, I want us to look at how the concept of material or physical matter came into existence. When we consider the origins of stable matter composed of atoms or molecules, it becomes clear that such matter did not exist during the initial stages of the Big Bang nor for hundreds of thousands of years thereafter. The early universe was a hot and dense environment filled with highly energetic particles that prevented the formation of complex matter. However, as the universe expanded and cooled over time, conditions became favorable for the formation of the first atoms. This process, known as nucleosynthesis, allowed simpler particles to combine and create stable atoms, such as hydrogen and helium. But this understanding doesn't address the question of whether something came from nothing. Going further back in time, around 1/10,000th of a second after the Big Bang, the first long-lived matter particles, namely protons and neutrons, emerged. These particles formed the building blocks of atomic nuclei. Prior to this crucial moment, there wasn't any material as we commonly understand it. But physics lets us keep on tracing the timeline backward to physical processes which predate the emergence of the Big Bang. The starting point of our observable universe can be perceived as arising from an almost negligible state. This concept arises when all the matter in a universe is gradually absorbed by black holes, which eventually dissipate into photons, disappearing into a vast void. Consequently, the entire universe originates from a state that, when observed from an alternative physical standpoint, closely resembles absolute nothingness. Yet, within this apparent nothingness, there exists a particular kind of something, a physical universe that is remarkably empty and devoid of traditional matter. This paradox of a cold, empty universe from one perspective and a hot, dense universe from another finds its resolution in a complex mathematical procedure called conformal rescaling, a geometrical transformation that alters the size of an object while leaving its shape unchanged. The cold, dense state and the hot, dense state are connected through this rescaling process, aligning their spacetime shapes while disregarding their sizes. Conformal cyclic cosmology unfolds in a unique manner, progressing from the old and cold state to the young and hot state. The hot, dense state is attributed to the cold, empty state, but this connection does not follow the usual cause and effect relationship. In these extreme states, size and time lose their conventional meanings. The cold, dense state and the hot, dense state exist on different timelines with distinct temporal geometries. From the perspective of an observer within the cold, empty state, it persists indefinitely in its own timeline. However, the emergence of the hot, dense state creates a new timeline with its own distinct properties and evolution. Penrose envisions a continuous sequence of new cycles, partly driven by his interpretation of quantum theory, where random quantum events unfold uniquely in each cycle. This perspective opens up the possibility of detecting remnants or anomalies from the previous universe by studying traces in the residual radiation from the Big Bang observed by satellites like Planck. Theoretical physics is currently on a quest for a unifying framework, a theory of everything, that can encompass both deterministic laws and probabilistic behaviors, offering a comprehensive understanding of the universe. Bridging the gap between determinism and probability lies at the heart of this pursuit. Philosophically, the question of how something could emerge from nothing has been contemplated through various arguments. The principle of ex nihilo nihil fit challenges the possibility of something emerging from absolute nothingness, urging consideration of alternative explanations. Leibniz's principle of sufficient reason posits that everything must have a sufficient reason for its existence, prompting a search for deeper underlying causes. Incorporating philosophical dimensions enriches our understanding by introducing arguments beyond empirical evidence and scientific theories. It encourages critical analysis of assumptions, questioning the nature of causality and existence, and exploring alternative explanations. Ultimately, the exploration of the universe's origin is an ongoing endeavor, revealing deeper mysteries that challenge intuition and invite contemplation of the fundamental nature of reality. The pursuit of answers, whether through scientific inquiry, philosophical contemplation, or interdisciplinary collaboration, remains fueled by an insatiable curiosity to unravel the secrets of our cosmic origins.